Friends, how are you? Welcome to my YouTube channel Enlightened Mind. Today we will be calculating the electric field due to the uniformly charged circular disk at a point lying on the axial line. So today what we'll do here is we'll consider a particular disk. Suppose the circular disk is in this particular shape, okay, and then we are asked to find the electric field at a particular point, and suppose uh, that particular point is lying on the axial line. So that particular, suppose that is the line which is passing through the center of this disk, okay, at point O, and is passing in this fashion. Suppose this is a particular axis and axial line, and this suppose is a point P. And first of all, you need to calculate what is the electric field at this point P because of the small portion of this disk. And suppose that portion of the disk is this much, okay, and this thickness of this particular disk, suppose small thickness is this much, that is very small, and that is the only thickness, suppose this much, and then you need to calculate what is the electric field because of this thickness of this ring, okay, at this point P. So let us assume that this is the radius small r, okay, and then you need to calculate what is this distance. If suppose this is your x-axis, okay, and this is your y-axis along this line, so if suppose this is the y and the distance from O to this point is small x, so this distance would be r, which is x square plus y square, square root, that we know, okay. And suppose this particular thickness is dy, okay, so this particular thickness here is, which is this much, is this one, which is dy, okay. So this particular portion dy would make an angle here, and if this angle is theta, then this particular small angle would be d theta, right? That is very easy. So just to make it simpler, let us make this diagram slightly in a different way, and suppose I will draw this disk in this particular fashion, okay. Suppose that is the disk, okay, in this fashion, and this is the axial line, and on this axial line there is a point P, okay, lying on the axial line along x-axis, suppose, and that is your y-axis, and this is the particular disk, okay, whose thickness suppose is dy. I already said, suppose this thickness is dy, okay. So this particular disk make an angle here, that is theta, suppose that angle is theta, and this particular small angle would be d theta, right? And this particular angle thickness of this ring is already said is dy. And if suppose this is y, okay, and this is your x, so that would be x square, that already said is r, okay, and which is x square plus y squares square root, okay. So our first task is to find what is the charge at this particular strip, okay, circular strip, that you need to know. And suppose this charge is dq, and that should be your surface charge density, which is sigma into area of this particular ring, and area of this particular ring would be 2 pi, okay, into this small radius, which is y, okay, and its thickness, which is dy, okay. That is very simple. Or you can write this as sigma into ds. So ds is the surface area of this particular small ring, okay. So now our task is to find what is the electric field because of this strip, and this, suppose the direction of this electric field is in this direction, in this fashion, and that magnitude is dE, and that can be resolved into two components, one along the x-axis and another can be here in this direction, which is along the y-axis. Okay, so dE, we know electric field small because of the small charge. dq at a strip of thickness dy would be 1 by 4 pi epsilon naught into charge, which is dq, and square of the distance between the point P and the strip, which is r square. Okay, and we know that r is square root of x square plus y square, so that can be written as 1 upon 4 pi epsilon naught dq divided by x square plus y square. Okay, so now you need to calculate what is the electric field along x-axis and along the y-axis. Okay, so along x-axis we know that the electric field is dE. If suppose this is the angle theta, so that should be theta. Okay, so that would become dE into cos theta. Okay, and likewise the electric field along y-axis should be dE into sin theta, and that we will calculate separately. Okay, so now suppose the electric field along x-axis, okay, is Ex, that can be written as dE into cos theta, and then you need to integrate. Okay, and integration sign basically shows when your y would become from 0 to up to this point, which is suppose is capital R. Suppose this the whole length of this particular thing of radius is capital R, suppose that is the real radius. Okay, so the surface charge density would be total charge, which is Q, divided by total area, which is the area of the particular disk, which is pi r square. Okay, so you can write this as Q divided by pi into capital R square, because we have considered that the area and the radius of this particular disk is capital R. Okay, so in this fashion you can write that the electric field along x-axis should be from dE into cos theta, and dE is 1 upon 4 pi epsilon naught dq upon r square, which we have calculated is x square plus y square, and then you will have to write what is cos theta. So cos theta is basically based upon hypotenuse, and here if theta is, this is the theta, so base is x and hypotenuse is this much, which is x square plus y square square root. So you can write this as equal to x divided by x square plus y square square root. So that would become, you can write this q can be written as sigma into ds, right? So that would be 1 upon 4 pi epsilon naught sigma into ds, and that was 2 pi y into dy. We already have calculated. That was the surface ds, surface area, which is small surface area because of the strip of the ring of thickness dy, and that was 2 pi y into dy. So you have put this value here, okay, in place of dq, and divide by these terms, so that would become basically x square y squares power 3 by 2, and another term which is x is here, so you can write x over here. Okay, and then you need to integrate. Of course we know that the distance of this x remain constant. Okay, so when you integrate, or you go from this points O up to radius r, so basically your y is changing from 0 to this much, which is r, capital R. So you can write x common, you can take x out of this particular sign, so only thing would remain is x and sigma, and 2 pi would come out, okay, of this integration sign, and 4 pi epsilon naught is there. So integration is for y into dy, okay, and divide by x square plus y square power 3 by 2. So that can be done, can be resolved very simple. That is very simple, so you can do it very easily. So some of these terms would be cancelled out, so you can write this as equal to 2a and pi would cancel out, so only 2 into sigma epsilon naught would remain, okay. 2 and epsilon naught would remain, x into sigma would remain, okay, and that is from y is equal to 0. I already said from y is equal to 0 to capital R, because what we are doing here is we are going from center to up to this point, edges of the disk, and the radius of that particular disk is from y is equal to 0 to y is equal to capital R, because here y is 0 and at this edge y is become capital R. Okay, so you are going from y is equal to 0 to capital R. So you can have put this value here. So that would become y into dy divided by x square into y square's power 3/2. Okay, so that very simple. Now what you will do here is you just put this limit x square plus y square is equal to u square, and that would become, because x is constant, that would become 0. So 2y into dy would be 2u into du. So you can write y into dy is equal to u into du. So you can put this value here in this equation, which is 1. Okay, so you can write this as equal to, so electric field along x-axis would be x into sigma divided by 2 epsilon naught, and limited from y is equal to 0 to y is equal to capital R, and y into dy here in this case is u into du. You can see here. Okay, so that will become u into du, and here is equal to u square, because x square into y square is u square, it's power 3/2, so that becomes u square and its power is u 3/2. So you can write this here as 3/2. So 2 would cancel out and u3 would come out, so 1 upon u square to du would remain here, but this power is for y is equal to 0 to y is equal to capital R. That need to be kept in mind. Okay, so that would be x into sigma upon 2 epsilon naught. So you just need to integrate that particular thing, so that would become x into sigma upon 2 epsilon naught, and that would be minus 1, and u's power minus 1. That would be the integration of that particular thing, and that is y from 0 to y capital R. So you can take minus sign common, so that become minus x sigma upon 2 epsilon naught, and that would become 1 upon u. Y is equal to 0, so y is equal to R. So what you can do here is you can put the value of u here again, because u square was x square plus y square, so u would become square root of x square plus y square. Okay, and that would become minus x sigma 2 epsilon naught in division, and that would be 1 upon x square plus y square square root, and here is the limit for y is equal to 0 to y is equal to capital R. Okay, so you can put this value of y here for r and 0, so that would become minus x sigma 2 epsilon naught, and that would be 1 upon x square plus capital R square square root minus, and when you will put y is equal to 0 here, only x would come out. So that would be the electric field along x-axis, and surely that can be written in a much better way, and that would be x sigma upon 2 epsilon naught, and in square root, if you take this minus sign inside that bracket, so 1 divided by x would come first, and then that would become in the second place, which is x square plus r square square root. So that is the electric field along x-axis, so that should have a unit vector I. Okay, so now let us calculate the electric field because of the y-axis. Okay, so along y-axis we know that the electric field was dE into sine theta, and again y was going from 0 to capital R. Then now you really need to calculate what is this electric field become. Okay, so that would become y is equal to 0 to y is equal to r, and that was 1 by 4 pi epsilon naught, and that was 2q, that was q, which was sigma 2 pi y dy divided by x square plus y square, which is r square, and sigma is sine theta is basically perpendicular by base. And when you take this particular diagram, you can see that this is your perpendicular, which is y, and hypotenuse is r square, r, which is x square root of x square and y square. Okay, so you can put this value here is equal to y divided by x square plus y square. Okay, and that is in square root. So you can write this particular thing as equal to 2 pi sigma upon 4 pi epsilon. So that would come out, and limit is from y is equal to 0 to y is equal to capital R, and here that would be y square divided by x square plus y square 3 by 2, okay, and that is dy. Very simple. Now you can see this thing very simple. If you can see here that this particular thing is basically is an even function, okay, that is an even function, and then you really need to integrate that particular thing. That we will do here now. Now from to calculate this particular thing, we will depend on the argument of the symmetry. If suppose we have this particular disk, okay, and the electric field, because of this element here, okay, this particular ring is in this particular direction, okay, and that electric field is dE. The electric field along x-axis would be dEx, and along y-axis would be dEy, okay. For that particular thing we have an electric field here, so for every element on upper side there would be an element at the lower portion which would exert an electric field here in this direction, and the electric field along y-axis would be cancelled out, okay. So because this dE can also be resolved into two components, one along the x-axis, y-axis here, and other along this axis, along x-axis. So what ultimately the electric field along y-axis would be in such a fashion, in such a way that the net electric field along y-axis would be 0, okay. So the electric field is only along the x-axis. For if you will take this element here, so another element would be present here when the electric field of these two would be cancelled out, okay. So in this particular argument we can see that the electric field along y-axis here in this case, which is this, should be 0, and the electric field along x-axis we already have calculated, and that electric field was this, okay. So the net electric field, you can say E is Ex along an I plus Ey and J, and this basically is 0. So the net electric field here in this case would be x into sigma divided by 2 epsilon naught 1 upon x, okay, minus 1 divided by square root of x square plus capital R square, and that is along the I or the x-axis. So that's it, friend. That's the end of the lecture. So I hope this lecture would be very helpful to you. If you like the lecture, you can click on the like button and subscribe my channel if you hadn't done that yet. So thank you for watching my video. Thank you very much.